Computational thinking in the primary school setting. Welcome. My name is Grant Jones and I am an instructional leader from Jordan Springs Public School in Western Sydney. And I'm here to talk to you about how computational thinking can be integrated into the classroom, into the primary school classroom. When we look at computational thinking, it's not thinking like a computer, which is sometimes a little bit of a misconception. What computational thinking is, it's a technique used to solve problems logically. And we're looking at problems on a big scale, not really small problems. When we look at the Australian curriculum, this is how they have defined what computational thinking is. So a problem-solving method that involves various techniques and strategies that can be implemented by digital systems. Techniques and strategies may include the organising of data logically, breaking down problems into parts, defining abstract concepts, and designing and using algorithms, patterns, and models. And that comes straight from the Australian Curriculum Technologies Glossary. So what I'm going to do now is break that down into the nice, easy steps. So the first time, when we're looking at a big problem, we look at decomposition. Then we have a look for our patterns. Are there any patterns emerging? Abstraction, so we'll delve deeper into that shortly. And then algorithmic design. So when we look at decomposition, what we're really looking at is how we can break this problem into small manageable parts. So the student doesn't get overwhelmed. We can really lessen the cognitive load if we teach our students to break the problem down into small manageable parts. Once we've broken them down into those small manageable parts, we can then start to develop a nice systematic step-by-step way of undertaking this problem. Here's a wonderful example of decomposition and where it can sit within the curriculum. So this comes from Robot Resources on Twitter, and I've got the Twitter address there. What this poster was really talking about is what decomposition is in primary terms, breaking apart, early years foundation terminology pieces, and then all around the outside are things that we already do in the classroom that actually do break things up. And what I do when I'm introducing the concept, so I introduce these concepts all the way from kindergarten up to year 6. I talk about if I put a banana in the ground, a banana peel in the ground, it starts to break apart, decompose, and so start to build that understanding of what decomposition is. And as you can see, just there up on the left, break down a word phonetically. That is an amazing thing that we do from kindergarten all the way up. And so the students actually know these skills that I'll be talking about. It's just really packaging them in a different sense. So after we've broken our problem into smaller parts, we come to some pattern recognition, and that in itself is looking for similarities or trends. And we look at patterns and we look at matching right from an early age. When we look at pattern recognition, we might be looking at even numbers, odd numbers, counting by 5s, counting by 10s. All our multiplication facts look for similarities and trends. And looking at rhyming words. So students are exposed to the concept of pattern recognition straight up in kindergarten. So when we start to delve deeper into packaging computational thinking in our students' minds, they already know the concept of pattern. It's just showing them a different way to look at it. Our next one is abstraction, and this one is quite interesting when we look at computational thinking, because this is something that students sometimes have a really difficult way of tackling this portion of computational thinking, because it's focusing on what's important and ignoring the rest. And I find that students sometimes can't do this as well as others. So focusing on what's important and ignoring what's unnecessary. So when you're looking at the big problem, it's actually, once we've decomposed and we've got those smaller problems, it's just focusing on that first part of the problem, or then the second part and third part and so on. So it's really important that we are teaching our students to just focus on those small bits, small manageable tasks, to then build up to a bigger picture. So we do all of these, creating a model, packing for a holiday. There's a few other things there that if you actually look, you go, oh, yes, I do that in my class. I do that in my class. So it's really important that we have a go at getting our students to work out what's going on with abstraction and worrying what's important and ignoring what's unnecessary. And sometimes I do laugh and giggle every so often when I do talk about abstraction, because sometimes students have to see the big picture. It's like, no, let's just look at the smaller picture and ignore what's not necessary. And sometimes students have a bit of, they worry about everything, and they only need to worry about what's important to them at that point in time. After we've broken up our ideas and our problem into smaller parts, and we've seen some pattern recognition and seeing some trends and similarities, we're worrying about just portions of our task with abstraction. We can start to do the algorithm design, which is making our step-by-step algorithm to see if our code's going to work, okay? So we, once again, creating step-by-step instructions, it comes from an early age. We've all done some cooking in kindergarten where we need to do the steps. Science, doing our step-by-step instructions to complete the task. So it's really, this one's quite good for students to do as well. And actually just writing their step-by-steps. And that can be in words, it can be with arrows, it could be with our blocks as we're coding. So once they've broken up, they've seen some patterns, they're worrying about what's important, they then create the design, okay? And that, in a nutshell, is what computational thinking is. Now, I always think there's one part missing, that normally they're our four main areas of computational thinking. I look at this and I say, you know what, I think this extra step, some people put it in, some people don't. I love to put it in. And it's called debugging. And it's checking your steps. And you need to make your code work. So what I find, once the students have created their step-by-step algorithms, go and test it. If it doesn't work, what didn't work? So getting your students to be debugging is really important, so they can self-regulate and actually look at where the errors are. So sometimes if you're doing an online coding activity, they can watch the steps, watch their code moving, but actually watch the steps. And some programs highlight exactly what's happening on the screen so that they know where the error has occurred. If you're doing robotics, for instance, and your robot goes off in the opposite direction, you'll be able to see as the program is running, that you can stop the code. If it goes off in the wrong direction, you can press stop. With some robotics, debugging, you have to clear everything. For instance, if you're playing with a B-bot, unfortunately, B-bots, they were quite early in the programming sense and with robotics. And if your B-bot goes the wrong way, you have to clear the entire program before you can, and then have to re-enter it. Where if you're controlling your Bluebot by an iPad, you can have the instructions down the side and actually flick off any issues that don't work and then redo the code. So you don't have to completely completely get rid of it because there are still steps that you can keep there. You can just delete the ones that aren't working. So that in a nutshell is what we're looking at with computational thinking. So what does that look like in the classroom? So definitely digital technology curriculum really pushes us to use computational thinking in the classroom, and it sits beautifully with mathematics. So what we're looking at, we've got some plugged activities and unplugged activities. So in a nutshell, plugged activities means we're using a computer, unplugged means we're not using a computer. So there are a huge amount of plugged activities that you can be doing on the internet. One of my favorites, and why I steer people to code.org to start with, is because it is very neatly packaged. It grabs students' attention with their themes. So they've got Angry Birds, they've got Star Wars, Minecraft, a couple of other Disney, Ice Age, and a whole range of different coding activities that build on skills over the course of, and it really came out when the hour of code. So when students complete a range of activities, it should come to about an hour. What I like about this is from so early stage 1 and preschool, and then they move up. So we start off with just arrows and directional plotting of codes with blocks, and then we start to move on to words and degrees, and we start to look at pixels and all sorts of distances on there. So it has a really nice progression throughout this whole website. And what I love about this, you can actually run the program, see what happens. You can also step by step, so you can actually watch and see how it's highlighted there. That's showing you that A, it's linked, but then when you press play, it shows you, okay, that's where I'm at the moment. What I also love about this is it's transferable to an unplugged activity. So I'll move on to my unplugged activity. So this activity here, as we can see, it's all in squares, can be transformed outside. So just a little anecdotal experience that happened to myself. I was doing some shoulder-to-shoulder teaching with a colleague of mine, and we were about to do coding with Angry Birds, and surprise, internet, we had some issues, and we couldn't use the internet. So we went outside, we grabbed 30 hoops and did 6 rows of 5, put a couple of bean bags out there, and we started to teach the students how to code in an unplugged sense. So what we were doing, we were instructing our students to move and to pick up the bean bags. So we looked at, okay, let's look at the track that our friends have to do. So they all drew a line with their finger in the air to see where our friends went. Then, okay, let's just focus on this bit. So we broke up each section. So there were about 3 or 4 different areas that they needed to go. So I said, okay, just here. Let's just focus on here. Let's not worry about everything else. Let's just break it up. This is what we're doing. And they had to go forward 3 times. And then we looked at, oh, well, there's a pattern emerging. We can repeat that pattern if we like. And then we go to abstraction and we say, okay, don't worry about any other hoops except for these 3 hoops that we're looking at here. Then how are we going to write that? We could write that as move forward, move forward, move forward. Or in our step-by-step instructions, we could have a repeat there and just say move forward 3 times. So what we do, we have to use, when we're looking at unplugged activities and plugged activities, we really need to work on using the same language and interchange it. So if we're using arrows here, we could use arrows in the classroom. I know with VBot robotics, I've seen people use, and I've used it as well, that you map it out with cards first, which is an unplugged activity. Where do I want my VBot to go? Okay, I want it to go forward 3 times, turn right, move forward 2 times, turn left, and move once. So then we have all those cards there. So that's my unplugged activity. Then I go and I type in my code into the robot and it starts to move. And so that becomes the plugged activity. So we can interchange quite nicely between them. You can always integrate coding and the computational thinking idea into the notion of dance in creative arts or dance in PDHPE, where they have to code the dance. So step forward, turn left, turn right, twirl on the spot. So you can have all of these different actions can become an unplugged activity ready, and then they could go in and code a robot to do the same dance. So once you start to develop an understanding of coding and how you can have this unplugged activity, and you don't always need to have a computer to be developing the computational skills. So just recapping on in my last few minutes is looking at computational thinking as a new way of thinking logically, and to really focus on creating as a new way of thinking, package new, but to look at a bigger problem. So it's really breaking down those problems into small, achievable, smaller problems. That's your decomposition. Then looking for some patterns. So looking for how we can, even when we're looking at repeat. So looking at how many times does something move forward? There's a pattern. Are we turning left 3 times? So it's all of those types of ideas, finding those patterns. Then abstraction, only focusing on what we need to at this point in time, because sometimes we're not going to actually get anywhere if we continue to look at the big picture. We need to break those up, then making up those step-by-step algorithms, and then obviously testing our code, and then seeing debugging if there is an issue. There's some great debugging activities on code.org. I encourage you all to go and have a look, because it really gets the students understanding how to debug and find the problems within the code. Jumping into the classroom, the plugged activity has to do with coding online. So that can be your code.org. Once they've got the understanding of coding with code.org, then move them. I like to move them onto Scratch after that. I like them to have a really strong understanding of that block coding before they move into Scratch. There's also Scratch Junior is a really great one to use as well. Unplugged activities is using the same concept, but not using a computer. So actually devising some coding to move around. It could be moving your friend around space, and it fits beautifully in with position in the mathematics syllabus. So I'd just like to thank you for listening today. I know that I'm coming up to my 20 minutes now, so I really appreciate you chiming in. I wish I was there in person if we were down in Melbourne. So hopefully 2022, we can all be face to face.